Let's do it.
We're doing some titanium welding today. It's a 3G weld test like you might take for aerospace. If you're new to titanium, check out my video on the 3 biggest mistakes you can make when TIG welding titanium. It's an eye-opener. I already posted a 2G video where I go over in detail cleaning steps and cleaning methods. That's very important for titanium. You should see a link about right here to check out that video. This is 036 6AL4V titanium. Again, if you're new to titanium, this might not be obvious, but you can't really get away with using the standard TIG cups. There are stringent shielding requirements for titanium, and the standard cups just don't cut it. Today I'm using a Furic BBW Sippy made from thermoplastic so it won't break. I'm going to be welding this practice piece inside a fixture that purges, so I'm going to set my purge to start with to about 15 CFH. Hope that's enough. Torch gas will be set at 35 to 40. Once it's in the fixture and tightened up, I'm going to get a couple of tacks, one on each end, and I'm going to put just a little bit of extra filler on each end, just a little extra dab. Gives me a little leeway when welding from and welding to keep me from melting the ends away. The D17.1 spec gives some allowance for melting the ends away, but you're not going to impress anybody by doing so. Once the tack welds are done, I'm going to stand the fixture up into the 3G vertical position and try to get comfortable. I'm using the CK MT200 machine. Usually I would set post flow probably to max for titanium, but since I'm welding inside a fixture with all that chill factor, I only need about 10 seconds. A TIG finger not only is protection for heat, but also gives you kind of a slide. It's really smooth, so it slides up and down a fixture like this, smooth as glass. That's going to let me kind of move along at a nice, steady, even pace. It just helps me glide along a lot smoother. Titanium filler rods get really sticky when they get hot, so you got to be really careful. You can't really scoot that filler rod into the puddle like you might on stainless steel. It really wants to grab like bubble gum onto the base metal, so you kind of got to aim to the hot part of the puddle. It looks like the cup is doing a pretty good job of shielding. Got a nice silver weld trailing there. I'm running about 45 amps here. That's going to depend on your travel speed and how far you have the chill blocks put in there and some other things. Somewhere between 40 and 45 amps though. I finally settled into a groove here where I'm feeding the rod almost right into that arc and it's not sticking at all with me. That's what I really want to do, but a little out of practice on this. I'm using a 0.45 diameter filler here, but actually I'd prefer one size bigger, a 1/16, just for the rigidity so it won't flop around and stick with me, so I can stab it right there in the hot part of the puddle. But I'm getting used to it. Okay, in just a few seconds coming up, I'll be welding into that very end tack. And watch closely when I do this and you'll see why I like to put an extra dab or two of filler metal on those ends. As I come in getting pretty close to that tack, I watch it really closely. I start to back off the foot pedal just a little bit. I watch the front of that puddle run into that tack, and then I start really getting off the foot pedal to keep from melting away that end. And that has worked for me really well on parts as well as tests. If you think about it, an actual aircraft engine part or something like that, you can't blow an end away. If you do, you got to fill it back in and sometimes bench grind it back off, and that would be really easy to blend back off and maintain original dimensions. That's why I do it. Well, that doesn't look too bad, but we'll take it out of the fixture and check out the penetration side. Make sure we got full penetration and check out the purge quality and see what we got. So far, the front side looks pretty good. We'll flip it over, and ruh-roh, that's bad. That's not acceptable on titanium.
That level of discoloration on the purge side on titanium is a big problem. And the reason it's actually more of a problem on the purge side than it is on the torch side, on the welded side. On the torch side, it might just be surface oxidation. It might be just something what they call alpha case, which is just a very thin layer of hardened oxide layer. That can be removed mechanically and it can be acceptable per some codes. You don't want it. You want the weld to be silver, but there certain class welds and certain codes permit some slight discoloration. It's best practice to go for silver, 100%. But when you see discoloration on a purge side, or if you're in a chamber welding, you kind of know it hit the molten metal, and that's bad. I'm going to bump the argon flow up just by 5 CFH, see if we can improve the discoloration on that root. Let's do it.
I'm going to bump up the fixture purge by only 5 CFH to 20 CFH, and we'll check it out and see if that does a better job. I have had some fixtures, some small fixtures, where it only required even 5 to 10 CFH for a good purge, but this one's pretty large, so 5 CFH more made the difference. I mentioned earlier that the cup that I used was made of thermoplastic, and here's the benefit of that. It can survive a crash a lot better. Hey, if you're interested in any of the gear that I use in this video, I'd appreciate if you'd visit weldmonger.com. That is how I pay for these videos. Thanks very much for watching, and thanks for your support. We'll see you next time.